Continuing on our beyondOne thinking, how would you like to have full text search and NATS in one binary? Here's my inspiration. Today's devices are so powerful, 64-bit energy efficient ARM processors with gigabytes of memory. What if you could write an application that has local storage and can also communicate and auto sync with the cloud and also have full text search? How can we do it? Come along for the ride. First, let's create a full text search index. I'm actually going to use an experimental package, Bluge, available from here. And our main program is trivial. Check that the correct parameters are entered. Create our embedded NATS instance. It's embedded with our software. And go ahead and create the full text index. So what does it do? Well, there are two main packages, package doc and package index. Package doc reads from roughly a 6,400 entry Netflix shows data set. And index handles all the indexing functions. And the main work here is done on line 29, batch add. So let's take a closer look at batch add. Batch add just calls add batch. And a few things I want to focus here. Line 72 creates a new batch. Line 76 is where the document is created. We'll go into that in a while. But first, let's look at line 77. That's where the data, the document, is added to the indexing batch. And at line 86, that is when the batch is committed. But let's look at the role NATS plays. I'm using NATS here for its key value store capabilities. Look at line 78. This is where we save the document into our embedded NATS key value store. So line 76, we create a new document. How is that document created? This is how. All right. Notice that new doc returns a Bluge document, creates a new document, and essentially we just add all the relevant fields. So in this case, let's say the first parameter here, title in this case, is star, the field name is title, and the value is Star Trek, for example. So let's go ahead and create our index. Let's clear this, make that a bit bigger. Well, notice Blue Index and JetStream. That's our key value store, and that's our full text search index. I'm going to kill it. Gone. No more. All right. Now we can add documents one by one, but that's slow and inefficient. So I'm going to add that 2,000 at a go. Let's see how long it's going to take. It's starting up. 2,000 done. It's indexed and it's ready for queries. So let's run some queries. But before that, let's go and build our binary, our single binary. So our single binary is built in the temp folder B search. And let's do a simple query. And let's see how long it takes. So this is how you read. Run the program and search for track. And you've got, well, NATS initialized. You've got TV show Star Trek here, right? And this is the relevant score, etc. All right, so it works. All right, let's do something more interesting. It searches the synopsis or description for the word Spock And here it only return one hit, and the description is Spock is there. I specified lowercase, but it takes care of it. Now let's do something a little bit more complicated. So I'm looking for star in the title and Kirk in the description. Lots and lots of hits. Let's page up. Let's see how many hits we have. We have 21 hits, and the highest score was 8.3. So Star Trek is there as the title, right? And Kirk should be, yeah, Captain Kirk, right? But let's make that a bit more refined. How do we do that? Use this query instead. This query says Kirk must be in the description and star should be in the title. Now we have only 2 hits. Star Trek as usual, right? And Kirk must be in the description. Well, Kirk is there. Here we have another thing. She's out of my league. That's the title. And Kirk is indeed in the description. Right. So there we have it. If you want to download the code and presentation, it's there on my GitHub. Thank you for listening.